Welcome to RGES Algebra 1. This is Lesson 30A. We'll be doing several things in this lesson, but make sure you have your homework with you so that we can go over that. And we're also going to go over Quiz 17 again, which a couple of you have turned back in, but there's still some confusion. So we're going to look at that, and then we'll get some new concepts going. So it's a big lesson here. Before we begin, I would like to start with this psalm. Just the first part of it. It's a wonderful psalm. I would commend the whole thing to you. But it says, Lord, you have been our dwelling place in all generations. Before the mountains were brought forth, or ever you had formed the earth and the world, from everlasting to everlasting you are God. And so I'd like to point your mind towards two ideas here. The first one is actually the second one in the psalm. From everlasting to everlasting you are God. That means God is always on his throne. He was always reigning. He does not change. He is all powerful. From everlasting to everlasting, from eternity past to eternity forward, there is nothing that shakes him or removes him from his place. So we can have absolute confidence. We can have him as our rock, the thing that does not change. This world is changeable. We all know that. It goes through highs, it goes through lows. Things can be steady and then very quickly turn upside down, and everything is threatened. But that is not so with our God. And so, because of that, he draws the first part of the conclusion there, is the Lord, you have been our dwelling place. So I'm going to choose to dwell in, abide in, hide in the one who is everlasting, the one who does not change. What does it mean to be our dwelling place? It means to hide within him, okay? To find our abode in him. How do we do that on a practical basis? What we do is we run to him. When this life begins to shake, we remember the one who is unshakable, and we run and put our faith, our trust, our confidence in him. Okay, so that's just a wonderful passage, and I would encourage you to meditate on that and to pray. You know, usually every time I think about the scripture, I turn it into a prayer. Lord, you're worthy. You're worthy to be the one I run to. You are the one I can be confident in because you never do change. You are always the same. You will always be the same. I can trust you completely. And so I choose to run to you in all of life's troubles, right? Something like that. We turn what we understand from the scripture into our prayer or praise back to him. Well, let's go ahead now and start with your word problems. We have 5 word problems on each of 11.9 and 11.10. So I'm going to walk through each one of those with you. Okay, these first ones, I noticed I backed them up some. I'm not having you do as many word problems here, but we're going to do the first 5, and the first 4 are ratio problems. Now remember, a ratio is like a fraction, A over B, and a proportion would be equals C over D. Recall that? We could cross multiply to solve that or whatever else. So the ratio of 2 integers is 13 to 6. The smaller, well, what would be the smaller one? That would be the denominator, is 54. Find the larger. Okay. Now we could do this several different ways. We could cross multiply. Sorry, let me get that adjusted here. Okay, we could cross multiply and say 13 times 54 equals 6 times x. and then multiply and then divide. Or we could just simply say 6 times what equals 54? Well, 6 times 9, so 13 times 9 would equal that. And so x has to be 13 times 9 is going to equal that. There we go. So x is going to be 90 plus 27, or 117. That's how you do it. So let's see if you can do the next one then. That was number 1. Number 2 says the ratio of two numbers is 7 to 11. The larger number is 187. So 7 to 11 is my ratio. This is the larger. So on my second fraction, I'm going to need the 187 in the denominator. Find the smaller. Again, I could cross multiply. I could say 11x equals 7 times that, and or I could see that 11 goes into 18, right? One time 11 goes into 77, 7 times. So 11 times 17 equals 187. So 7 times 17. Okay, if 11 times 17 equals 187, then 7 times 17 will equal my x. So that would be 70 plus 49, or 119. I think I did that right. 7, yep, 9, yep. Okay. Number 3. Another one, read it again. If you struggled with these the first time, read it, number 3, and see if you could set it up real quickly on your own. Well, actually, I told you to try to do this one on your own, and yet it is quite different. This one, rather than having the two numbers where we plug in one on the right, it says the, let's see, where is it? The sum. Okay, so this is the larger and the smaller, okay, is what we've been given. But now I want the sum on the bottom. Okay, so this has to be the sum, not the smaller. So what would I do? Well, the sum of the two is 16. Whoops, okay. Let's see how to show this. Okay, the sum of these two is 16. Okay, so instead I'm going to take the 9 over the sum equals, and what is the sum? It's going to be 1024. Okay, so this is going to be a larger number, right? But the proportion between these two numbers is going to be the same as between 9 and 16. So I'm trying to find out what would be equivalent to the 9. Okay. So you could think of the actual amount and the simplified amount. Okay, so I'm going to cross multiply for this one. I'm going to get 16x equals 9 times 1024, and when you, on your calculator, when you multiply it out and then divide by 16, you will get 576. Now, what is the 576? Well, that says that in my original ratio, 9 over 16, that's equivalent to 576 over 1024. So that's one of my answers. But what if I had set up the smaller number over here, the 7? Well, what would 7 over 16 equals what over 1024? Well, there's two ways, again, I could do this. I could have taken my 1024 and subtract 576, and I would get the other one, or I could cross multiply again and get 16x equals 7 times 1024. And when you take your calculator, multiply, and divide by your 16, you're going to get 448. So that's equivalent to the 7. So what I'm saying there is 7 over 16 is the reduced form of 1024 over 448. Oops, that's a 4, sorry. Okay, so those are my two answers. Got it? 448 and 576. So that's a little more complicated. Let's look at the next one. The ratio of two integers is 17 to 13. Their sum is 390. Now again, so if I given the sum, I'm going to put one of the numbers over the sum. So I'd have 17. 17 and 13 is 30. So that'll be the first one. And I'll take the other number, 13, and the sum is 30. So this is how I'm going to find my two equivalent fractions here. The sum in the first one is 390. The sum in the second one is 390. Struggling with my writing instrument today. Okay, and this would be 1x and this would be 1x. Well, a 0 goes into a 0. 39 divided by 3 is 13. So 17 times 13 is 221. What's the other way I could have done it? I could have said cross multiply 30x equals 17 times 390. Again, if I take my calculator and I multiply that out and then divide it by 30, I'm going to get 221, the same as I did before. So there's two ways I'm showing you how to do that. Sometimes that drives kids crazy, but I do like you to understand that there's more than one way to do the arithmetic. Okay, and again, in this one here, okay, I'm going to cross those and I'd get 13. 13 times 13 is, for my next answer, it'd be 169. Now, let's say I'm saying that's got to equal 390 together, does it? Yes, it does, right? So I did that problem right. So pause and think about it. If you haven't, if it doesn't make crystal clear sense to you, pause a little bit and think, what are we really saying? In other words, I'm saying, let's say 2/3 is the same as how many twelfths? That's one thing I'm saying, right? For the first two problems. Okay, 2/3 would be the same as 8/12. That's the kind of problem you're doing. This is an example, a simplistic example of what you're doing. I'm also saying 2/3 if the total was, let's see, to get together they're going to add up. So if 2/5, if the total is 100, then what would it be? Okay, because I've added these. So this now is the total problem. Okay, and so 5 times says 20, that'd be the same as 41/100. So these are the two types of problems we just did. Now let's look at number 5. Mayberry has 18 grandchildren on her son's side and 12 grandchildren on her daughter's side. What is the ratio of these numbers in lowest terms? So what is the ratio of 18, that would be the son side, the daughter, the sons to the daughter side, 12 grandchildren on the daughter's side. If we divided both the numerator and the denominator by 6, we would have a ratio of 3/2. So that's A. B, the elderberry divides 7,200 acres of land into 2 tracts whose areas are in this ratio. How many acres are in each tract? So now we've got a total. So we're taking our simplest ratio. Okay. The total is going to be 5, right? So we're going to add them together and make our new ratio 3/5 or 2/5. And in both cases, the total is 7,200 acres. How do you do that? You're going to cross multiply and then divide. And how could I check that? I would add those, and I'm going to get, yes, 7,200. So if you add this and this together, you get 7,200, which is what I need. Okay, so I would expect you to know how to do those 5 problems if the numbers were different. I'm not going to ask you for any others in 11.9 except those 5 problems with the numbers changed. Okay, let's look at 11.10. We've got 5 more problems. Okay, now these first problems are travel problems. And for travel problems, one of the things you need to understand is what happens when I'm going with the wind or against the wind. Can you figure that out? Are you familiar enough with life to know? Okay, let's think if I have a current. This could be true in a boat that's in the water. If the current is going that direction, and let's say I'm going 50, well, let's do something a little reasonable. Let's say I'm going 5 miles per hour, and I'm rowing, and the current is 3 miles per hour, then I'm really traveling 5 plus 3, or 8 miles per hour. But if I'm going 5 miles per hour, I'm rowing at that speed, and the current is going backwards or in the other direction, the opposite. I'm going to be rowing slower, so it's going to be 5 minus 2, and I'll really be effectively moving only 3 miles per hour down in the direction I'm trying to go. Does that make sense? So the boat's going this direction and the current's going this direction, then it's going to speed me up. But if the boat's going this direction and the current's going backwards, it's going to slow me down. That's kind of the key you want to think about. So here we have a blimp. Okay, a blimp flies through the air at a speed of 120 kilometers per hour. Okay, or I could write it kilometers per hour. Okay, like that. How fast does it fly with respect to the ground if it flies with a tailwind? Well, a tailwind will slow me down or speed me up? It will speed me up. So if the tailwind is 30, we started with 120, we would add 30, and our answer is now we will be going at 150 kilometers per hour. And I'm just going to make sure that all of this is clear to you. If we have a headwind of 20 miles per hour, it will slow me down. I'm flying into, or I'm moving into the wind. Okay, so I start with 120, but I'm slowed down by 20. And so now I'll be going 100 kilometers per hour. The next one, into a headwind of X. A headwind will slow me down, so I'll be 120 minus X kilometers per hour. And for the last one of this group, with a tailwind will speed me up, so it'd be 120 plus Y kilometers per hour. Now, we're going to apply that information in the next set. It says, how long does the blimp take to fly? So we're going 120 kilometers per hour, that still fits, is my basic speed, and I want to fly or go 60 kilometers. Okay, so this is my distance, and this is my basic speed that I'm going to alter, or my rate. What if I have no wind blowing? Okay, well, I'm going in 1 hour. I want to know how long. That's always the question. So time is always my question for these. So if I go 1 hour, 120 kilometers per hour is 100. I could write it either way, so maybe I'll write it this way. Maybe you'll like it better. 100 so my distance over my speed, whoops, I'm sorry, over my time. Let me find my marker again. There we go. In 1 hour. Okay. With no wind blowing, I have the same speed, right? But now I want only a distance of 60 kilometers. See how I'm using a ratio here? Kilometers and kilometers. So what's my time? Do a little cross multiply, and you get 120x. You probably could just see it in your head, but this would be half. And so this will be half. So this will be a half an hour. But if you don't see it in your head, cross multiply. 120 times x equals 60 times 1. Divide 60 by 120, and either way you get 0.5 or 1/2 hour. Let's go to the next page to continue on. Now it says against a headwind. So if I'm flying into the wind, that's a headwind, then that's going to slow me down. For my original speed was 120, but now my new speed is going to be 100 kilometers for 1 hour. And now I only want to fly 60 kilometers. That part's not changing, so I want to know what's the new time. Again, I would have 100x equals 60. If I cross multiply, divide 6, and you're going to get 60 over 100, or 0.6. And that's the time, 0.6 hours, right? The next one says, with a tailwind, that will speed me up. I start at 120, but now I'm going to add 30. So my new thing is, 150 kilometers in 1 hour. But I only want to go 60 kilometers. So I want to know what the new time is. Again, I'll cross multiply. 150 times x equals 60, divide, and this time I get 0.4. And that's my hours, right? And finally, with a tailwind of y kilometers. Well, a tailwind will speed me up. I started with 120, so I'll now have 120 plus y. That's the speed I go in 1 hour, but I only want to go 60. So how long will it take? And now you'll go x times 120 plus y equals 60, and x will be 60 divided by 120 plus y. And some of you can see that without going through all these little extra steps, but that's fine if you go through all the steps. I'm just trying to show you in a consistent manner. Now, so what is your trick? You decide how the wind is affecting your speed, and you're going to go, the second problem is the very same way. So you try to do the second problem based upon the first problem, and I'll just write it out for you. Okay, so all of this is the very same, except notice because they gave me the x as a special meaning here, I couldn't use my x for my answer here, so I had to change it to a new variable so you didn't get confused and start wanting to make those x, this x, and the x I normally use down below on the right side to mean the same thing. Now, we do have 3 more problems here. Okay, number 3 says, a blimp flies 120 kilometers per hour through the air. It goes 60 kilometers into a headwind of x kilometers, and later it returns 60 kilometers with a tailwind of y kilometers. Write an expression for the total time. Now recall from our last 2 examples that the time for the first part would look like 60 divided by 120, with a headwind minus x, and the time that would be going, and returning it would be 60 with a tailwind of y. So if that's not real clear to you, just go back to problems 1 and 2 and look towards the last section. And so an expression for the total time would be that. How long will the round trip take if the headwind is going 40 and the tailwind is returning is 10? So I would replace 40 there and 10 there. Okay, let's go ahead and do that. So simply doing that arithmetic, converting then at this stage into decimals and adding them together, you should get 1.21 hours. Now the next question is, if the headwind and the tailwind are equal to x for both parts of the trip and the round trip takes 1.3 hours, how fast is the wind blowing? Okay, now this last part is a little trickier. It says if the headwind and the tailwind are equal to x for both parts of the trip and the round trip takes 1.3 hours, how fast is the wind blowing? Now you're going to set this up. Okay, so we're still looking for the time. So we're going to go back to our original part here and we're going to set this up, but now the headwind and the tailwind are equal, so we'll have that and that. Whoops, minus, sorry. So first add it for the tailwind, then subtract it for the headwind, and it's going to equal 1.3 hours. Now to multiply this, we're going to need a common denominator, and so we'll get 60 times 120 minus x plus 60. Having trouble with my writing tool here. Yeah. There we go. Plus 60 times 120 plus x, my common denominator, right? And on this side then the common denominator will be those two binomials, 120 . Now notice when you go ahead and distribute this, you're going to get 7,200 minus 60x plus 7,200 plus 60x on the left-hand side. These will cancel out. And on the right-hand side, you're going to get 14,400. The middle terms will drop out, minus 1, well, let's see here, 1.3 times 14,400. Middle terms will drop out, minus x squared. Now, we're going to gather 7,200 and 7,200. You're going to get, I'll go ahead and divide here, and I'll get 11,074, or 077. I'll go ahead and subtract and take the square root. Okay, so you'll end up with x squared equals, okay, and so then you take this, whoops, subtracting, you're going to get this, and taking the square root, x equals that. So that's the speed of the wind. So I think that I'll leave off the last two. You do have the answers for 5, but go ahead and learn the techniques for 1 through 3. If you know the 1 through 3, and if I change the answers, you can get those, then I would be happy. Okay, now, the next thing we need to do is I want to go over the quiz 17, because you struggled with that, and I'll use that also for my review on on chapter 11, because you will be having a test on 11. So I'm going to go ahead and stop this tape and start a part 2.